this computer. I did not restart recording. Okay. I thought I did. So I'll record now, which is now that we're doing the activities. Let's go ahead and do. Okay, again, watch these videos if you haven't. Today we're working on this activity. You can find it by clicking here or by going to the project list on your textbook and going to generating a password XKCD style. So today we're going to learn about working with string. Module 4 does not exist. Does that happen for anyone else? Are you logged in?
Yeah, I'm logged in, but every time I try to click on module 3 or 4, it just says it doesn't exist, but 1 and 2 work fine.
Module 4 is on Canvas, right?
Oh, okay. Okay, yeah. Okay, apparently, so these buttons don't work. Got it. Got it. I'll have to fix those buttons. So those buttons on the bottom don't work, but I've never used those bottom buttons, so I never checked them. Okay, click on modules over here. I'll fix those buttons, and then go over to here to select what module you have. And you can go to all the modules that way. Although some of them are a little bit are like this one will need to be I'll be reworking them. So let's go to turtles, sequences, and for loops. Again, on Thursday so we'll be going ahead and doing this activity on creating random passwords. All right. So there was a pretty amusing comic I found a couple years ago when this came out, more than a couple, about the creation of passwords. Now, this is one of the times I get to praise IT administrators because Temple University actually has a very sensible password policy, which the requirements for your password become less complex the longer it is. So I can make a password with just capital letters and lowercase letters if it's long enough. So what's saying here is that basically we've got some uncommon base word, and then we just swap some stuff around, like the capital, like here's troubadour, capitalize some stuff, turn the 0 into an O, add in some random gibberish and what this gives you is some of what are called bits of entropy, which are just basically there's a bit of basically how hard it is for the for computer to crack. So basically saying, hey, if we've got a password and we're trying to crack it, but it's not that hard for the computer to crack it. Okay. On the other hand, it's very hard for you to remember. Was it trombone or troubadour? And how did I switch up what now? Right? And what were the symbols? Hard to remember, easy for the computer to crack. On the other hand, for us, let's take a look at this password. Correct horse battery staple. All that is 4 random words. It is very long. Takes about, and the amount of entropy, the amount of effort that basically of data that has to be sorted through to figure out what the password is much longer. And it takes about 550 years to guess for the computer versus 3 days for this guy. And remembering it's something you've probably already memorized. Correct horse battery staple. So the tagline for that was, through 20 years of effort, we have successfully trained everyone to remember passwords that are hard for humans to remember, but easy for computers to guess. So what we're going to do is create a we're going to see, so this is going to be talking about, so this is going to be kind of a demonstration on how to generate passwords. And then at the end, we'll have a bonus exercise about how do we how can we crack a very short password? How long does it take to crack it? Right? So let's start off by creating a traditional random password composed of numbers, letters, and a few special characters. So first off, we've got letters, capital letters, and numbers. Now, for those of you who haven't had the chance to watch the video, and those of this will be a bit new, but for those of you who have, this will be slight review. Right? So what is this over here? This thing between quotation marks?
It's a string.
Right? A string. It is a string. In other programming languages, it might be a string of characters, but there are no characters in Python per se. There's just simply strings. And strings are what we use to represent text. So we have two ways of representing strings, we have a couple different ways of representing strings. The most common way is to surround it with either quotation marks or single ticks, apostrophes, essentially. Both those are equivalent. They both mean a string. It just has to begin and end with the same mark, right? So you can use single quotes or double quotes. Make sense? You can use either. They just have to match. If they don't match, the computer will start freaking out. Okay. There is one other way we can do that. So a string can be of any arbitrary characters, right? So it doesn't have to be letters. It can be anything we want in there. But also we could do, but it also includes the white space as well. If we wanted to capture like a lot of white space, there's other way to write a string. Multi-line string over here is equal to, hello, this is a string that is on multiple lines. Done. Okay. And I'll just go ahead and print to show you. And I just want to show you this. Print multi-line string. And it prints out this entire everything between the three quotation marks. Okay. So, see, so we sometimes use that as a multi-line comment, just by having the string just hanging out, being assigned to nothing. That's one way we can do that. But I just wanted to show you that exists in case when you see it. So there's a couple cool things we can do with this. I showed you at the end of last lecture, just kind of hinted at this, that we can do something like 4 letter in letters, right? 4 letters in letters, rather than doing like a range function or going by indices like you would be if you're coming from another programming language. You can say for every, actually you kind of read it as for each letter in letters, for every letter in the string letters, print the letter is, which I don't have to put the letter is or anything. I'm just putting that, saying that because I can, right? And it prints out every one thing. So this is a sequence. We're going to be working with a lot of sequences, but anything that's a sequence, like a string, anything that's made up of little bits of stuff, you can iterate over. A number is not considered to be made up of little bits of stuff. You can't iterate over the digits of a number. But a string, each letter is its own individual kind of special unit that has its own distinct meaning. So it can be separated out like that. So now let's look at the objective over here. Make an 8-letter password by combining characters from all 3 strings. So we want to create a traditional random password. So any guesses as to what library I'm about to import?
Random.
Oh my God, how could you have possibly guessed that? It's yeah, random. We're going to do random. And in fact, now other programming languages make this a pain to do, but I love that in Python that we've got this. So I'm just going to print. Okay, I'm going to go ahead. I'm going to just call this the chosen, because, that makes it sound way more pompous and important than it actually is. Random.choice letters. So you can take random and you can call the .choice function on it, pass it the thing you want, the sequence that you wanted to look at, and let's see what happens. Print the chosen. This is the chosen one. Specifically, it's an L. Looks like a 1, but it's a L. Q, L again, R, T, F, X. Now, why isn't getting any capital letters? Not a trick question.
Because there's no capitals in the string letters.
Right. There are no capitals in here. If I wanted to get any of the capital letters, I'd have to say print from caps. Or not print caps, but print the chosen. I'd want to select from caps. Okay. So that's clue number 1. You can choose something by using that. Clue number 2 is how to glue a string together. Right? So we kind of been hinting at this, but you can take letters plus caps, and you can add, and you can do the addition operation on these guys. Right? And what the plus operator does is that it glues them together. So there's a common pattern called the accumulator pattern. And what we're going to be doing with this a lot is that we will basically be having output. Output is equal to quotation marks. And then what we could do is say for letter in letters, output plus equals letter. Now remember, output plus equals is the same as saying take what's currently in output, add letter to it, and store it in output. But what this really translates to is just tack letter onto the end of the output. So what you want to do is that these are all different clues. They're different puzzle pieces. You'll want to put some inside the other. But this is kind of all the puzzle pieces you need to generate a random password. So I just shared it with you. So to get it, what you do is that you refresh the page and then again, hit load history and it'll have the history of what you have over here. So I'll give you a couple minutes to work on this. I'm going to check on my poor, and while you're doing that, I'm going to check on my poor son who has had no cake. So I'll give you about 3 minutes to work on this. Huh. All right. So, any solutions so far? I know that wasn't a lot of time at all.
I didn't hear the question, but were we trying to figure out how to make that it would get, instead of just printing out them in order, to get them to print random letters?
How to make it's to make an 8-letter password. Sorry.
Yeah. What I did was that I did for output equals random choice letters plus random choice caps plus random choice numbers, and then I did for I in range of
Mhm.
1 to 9 print the output.
Close. Yep. Okay, so let's go ahead and X in range 8. Yep. So Abir, what you have is almost completely complete. What Abir posted in chat. Because that will just select from caps unless you changed up what you had beforehand. So let's go ahead and show what the actual answer is. So again, the task here, which I kind of said, but it may not have got into your attention with all the other stuff going on, which is totally understandable. Make an 8-letter password by combining characters from the 3 strings. So let's go ahead and make a string called combined, because that's a better name. Combined is equal to letters plus numbers plus caps. You can do that in any order, doesn't matter, right? Just all the things have to be there. Okay, so Ryan, I will go ahead and now put that in. So and what we're going to do is we're going to create a password. And what we're going to do is that basically this is the equivalent, the string equivalent of setting password equal to 0. This is basically if I add something to an empty, this is the empty string. If I add something to an empty string, then the answer is going to be whatever I added what I added. So empty string plus hello is hello. Hello plus empty string is hello. Hello world plus empty string is hello world, right? And this is useful when we want to do what's called an accumulation for strings, right? Accumulation, that's where you loop over something and basically add everything together. Here we're trying to add, instead of trying to add numbers, we're adding letters, which is a lot easier because all you have to do is glue it together. I mean, come on. I mean, the math is super easy here because it's super intuitive, right? Watch. So 579, the string 579 plus 22 is actually very easy because it's 57922 when we add strings together, when they're strings. Right? Which is what we've got here. So, next, let's see, okay. So we've got our password, and what we're going to do is we're going to say for I in range 8, because we want this to happen 8 times. What are we going to do? We're going to choose a random character from the combined selection. Okay, and then we're going to say password is equal to password, what's currently in the password, plus the chosen character. print. Password. So now if we run this, we get a completely random looking jumble of characters. Something that's 8 characters letter long, hard for us to memorize, but believe it or not that hard for a computer to figure out. Because what the computer has to figure out is, well, there's 26. Well, let's do some basic math. Idle again. Okay, so let's do some, so we have 26 letters times 26 letters. Yep, things are a lot simpler than they appear in Python. We have 26 letters plus 26 letters plus 10 digits. So we've got 62 possible characters. Yes, Thomas, you are correct. We could do it in one line. I generally avoid one-liners like that in my intro class, just simply because it's easier to read and break it up. That way you can say is what. That way each line has a distinct function. It has a distinct operation, rather than doing multiple operations. It makes it easier to learn. But you're free to do it yourself on your own code. So, all right, we've got, so 26 plus 26 plus 10. That's because there's 26 letters, 26 capital letters, and then 10 characters, right? Our thingy was 8 long. So, let's see. Let's see, I'm just checking that code over there. Yes, you can do it like that too, Kyle. If it works, it works. So let me get back to this. So we have 8 characters. The first character, we've got 62 possible choices to make from it. The second character also has 62 possible different choices of what it could be. The third character also has 62, right? All 8 characters have 62 possible choices. So that's 62 to the 8th power, which means there's this many possible passwords. All right, so let's do some basic math here. Or not so basic math, but easy enough to understand, right? Let's go ahead and assume that we can do 1,000 guesses a second, right? That would mean that it takes that many sorry, that's 100. That would mean it takes that many seconds to do. But seconds is a weird number. So how many, so how long? So 1,000 seconds, and then there's 60 seconds in a minute, 60 minutes in an hour. So 60 minutes in an hour, 24 hours in a day.
I have a question. Why is it not necessary to put 62 to the 8th power in parentheses?
Exponentiation takes a precedence over everything else.
Oh, okay, thank you.
So not too bad. But mind you, this is assuming 1,000 operations a second. So 60 seconds a minute, 60 minutes in an hour, 24 hours in a day, and then 365 days in a year. So, hey, that's pretty good for if we're dealing with 1,000 operations a second. But if we're dealing with multiple computers working at once, let's say I've got, you're the president of the United States, and I want, so maybe I'll just use 1,000 computers, each doing 1,000 operations on this. Suddenly that just takes 6 years. And of course, if my computers are actually much faster, right? If they're more doing 1 million operations a second, as opposed to working off of a laptop, suddenly it's not taking much time at all to crack a single password. Make sense? So next, let's go ahead and take a look at this. So here we have a list of, we have lists. Well, we have lists. So lists are really powerful. They're exactly what they sound like. They're a list of things. Lists of things are, well, basically in between braces. This is an empty list. This is a list with one thing in it. It is hello. I will get to that in a second. This is a list that has hello world in it. Now, I just got a very good question over here. Mr. Wen asks, since we use the star for exponentiation, does the caret do anything? And the answer is yes, it does. Watch. So let's do 100 squared, shall we? But with the caret. Wait a second. That's not 100 squared, right? Anyone know what this operator is?
And
Close. You're definitely in the right direction.
Replace the last
Is it like
number.
reset?
It is a Boolean operation. That's why I said the and was in the right order. So there's some weird mathematical operations you definitely don't need to worry about, because this is more for like weird number trickery that people who are, if you have to use this, you're already you're already in an area where it's just you're in pain, right? 102 gives you 0. 100 or 2, and what we've got over here is the Zor operator. So what is Zor operator? So Zor basically is what we call a binary operator, like in the sense that it works on binary numbers, meaning that we take 100, we convert it to binary. We take 2 and convert it to binary, and if the bits line up, we will they get flipped. So here, asking all the interesting questions. So let's go ahead and do annotate. So what is 100 in binary? Well, how you wouldn't know that, but that's okay. So what we need over here is 0. We need some bases. So so let's go ahead and do 1, 2, 4, 8, 16, 32, 64. So for 100, I need 164 and a 32. That brings me up to how much? 96, right?
yeah.
And so I need a 4, right? So this over here, 110, 0100, that is 100 in binary. Making sure I didn't do anything stupid. That's very easy for me to do. Okay. And now 2 is just simply 10. And what the Zor operation does, it says, hey, if there's a match, it's a 0. If the two numbers don't match, it's a 1. 0, 1, 1, 0, 0, 1, 1. If the digits match, it's a 1. Sorry, it's a 0. If they don't match, it's a 1. Like I said, this is basically this is emulating something that happens on the hardware level. And so this becomes 102. We can learn more about binary later if we want to. It's not actually that hard. It's actually pretty easy. But it's one of those things, like, as I just kind of demonstrated, that really what you want to do is have some pencil and paper. Okay.
What is the purpose of this?
Somebody asked. Somebody asked what?
Addition. Right. Is this similar to addition in it?
Oh yeah. You utilize it in what's called an ALU to perform addition. Or no, not an ALU. You use it in an adder to perform addition. Basically, it's something I can talk about later as we learn more, but I can show you on the hardware level how basically you can take these things called gates and put it together and create something that adds numbers together just from using a couple circuits that you create. But these these and, or, and Zor, what are used for those. So it does help with addition. Now going back, now that was just asking from somebody asking what is the caret operator. Now let's go back to this. So now we want to take this and follow the XKCD model of selecting 4 random words and concatenating them together to form our password. So what does that mean? We want to take 4 random words. So we want our password to be equal to that, right? Print whatever our password is at the end, right? And we want 4 random words, 4 I in range. So we do this 4 times, right? We want 4 random words, right? So first things first, I need to get all these noun, verbs, and adjectives rather than being in one list, in 3 different lists. It's probably going to be easier to put them in one list. Okay, right? Any guesses as to how to do that?
The same thing we did last time where you add nouns, verbs, and adjectives together.
Right. Right. Just like we did up here for caps, letters, and numbers, we can add these together. Python operates under the principle of least surprise, which means that, you know, ABC plus DEF is equal to that. And so here, if I have a list of 3 numbers and a list of 3 numbers, adding them together, right? These are sequences again. So adding sequences glues them together. Does that make sense to everybody? When we're dealing with sequences, they get glued together. Why doesn't it add the numbers? Well, because we also might we might get into a situation like this, and we want our rules to always be consistent. So when we've got sequences, be it strings or lists, when we add them together, they glue together. Make sense? Fancy word for that is concatenation. So password. So what we'll do is we'll say combined is equal to nouns plus verbs plus adjectives, right? Now, and I'll just put pass over here and share the code. So what does pass mean? That basically means don't crash. Just don't do anything, but don't crash. It means I'm going to put something in the indentation, but I have to have something indented for it to run. I just did. I just shared the code. So just shared the code. So hit F5 on your page, hit load history, and then did I not do that right? Boo. Did I not load, give the history? Boo. Let's see. So did the code get to anybody or no?
I got it.
You got it? Great.
I got it.
Cool. So just hit reload, just hit load history and you'll be able to get it. Although apparently I didn't get it. So, oh well. All right.
I got the code, but on my part, nothing really printed.
Well, there's nothing that's gonna print. What you got to do is now adjust it like you did over here. So I want you to solve it by basically creating a password of 4 random words. Got it? So you got to fill in the for loop to do the 4 random words. And again, this is one of those things where it's actually easier than it appears to be. Okay, so I'm going to give you guys, I'm going to wait 20 more seconds. Pass just means please replace this. Pass is a placeholder. A space in what? Oh, no. No, because it's going to be all one. Okay, so who had, let's do the exact same thing we did before. as their answer because that was the answer. So all we're going to do is, so I'm just going to simply grab this from up here, paste this down here, and instead of combined being nouns, verbs, and adjectives, I'm just going to change it to nouns plus verbs. So instead of being letters, cats, and numbers, it's going to be nouns, verbs, and adjectives. Let's see. Oh, verbs. Random is not defined. Import assuming it can spell, it's import random. And there we go. We have, change this to 4 so we get 4 random words instead of 8. Invest, isolated, illness, repeat. Ominous. Isolation, mountain, informal join. Limit, evil, question join. Question free, represent, quality. Right? So all that we did here is that, just like we did above, is that we took these sequences, this list of nouns, this list of verbs, and this list of adjectives. And what is a list? You ever make a shopping list? There you go. That's what a list is. A list is a collection. It is an ordered collection of things. And what we did is that we just simply combined all of our lists into one list, right? That makes sense. Just take them and glue them together, became one mega list. And we created an empty password. And what we said is, okay, rather than choosing a letter, what I'm going to do here is I'm going to do random.choice on combined. Combined up here was one big mega string, right? So every time I selected from it, it was one letter. Over here, though, we've got, instead of a mega string, we've got a mega list, right? A list that's just been glued together. The mega is totally an informal term that I am just using here to make it sound mega awesome. So random.choice combined, right? We're choosing from here. We've got and we choose a random word. That's what the chosen is, rather than being a letter. And then we just simply add that to our password. So here we had colony, horrible, suggestion, perfect. Okay. And then all glued together in that word, it becomes colony, horrible, suggestion, perfect, which is actually a pretty long password. Okay. So let's move on to the next exercise, which is, of course, that does not make the IT department happy. It does at Temple, actually. They still want you to have at least one capital letter and a number in your password. We'll learn more about this in a couple chapters, but it's easy enough to replace strings, parts of a string, with a different string using what's called the replace method. So for example, this is some example code over here, which is if we do pool.replace O and E, that turns it into peel. So once you have your final password, what we can do is that we can replace some stuff like E with 3 or O with 0 or L with 1. So let's take a look at this. So watch this. So watch what we can do here. So here's some basic functions we can do. Word.replace O with E. So this says, hey, find any O's, replace it with an E. If I replaced it with this, what would we get, by the way? What would word become? PL. Yep, you got it. Not as hard, right? Again, principle of least surprise. If I said replace all the A's with empty string, what would I get? Pool, right? There's no A's to replace, so it remains the same. Okay, so if I decide, right, if I said replace all the O's with zeros, we would get that. Okay, so then we also show that there's a word called capitalize. Now notice that basically in these, we always say word is equal to word.replace. Okay, now this is very important. Strings are what we call immutable. Just a big fancy term that's that means that you can't change a string, right? You can't change a word. Why? Just because that's the way we decided it. It works. In fact, this is the way it works in most programming languages. You can't change strings, or at least, actually, no, it works in the languages you're going to be working with. So I don't know if it's the same case in other programming languages, but in Java, yeah, strings are immutable too. So what happens is actually when we run word.replace, what this does is it generates a new string for us. So it creates a new string. Right? Make sense? It generates a new word for us. Yeah, Justin, I was tempted to do that, but you know, that's a joke that my toddler would appreciate. And so do I, but yeah. Okay. So this is pretty, so over here we do the same thing with word.capitalize. And what that does is that generates a new word with the first letter capitalized. Okay. So so what we can do, so let's go ahead and, so what we're going to do is that, I don't know why I didn't do this, but I'm going to go ahead and grab this code, copy. Going to go ahead and paste. Let's go ahead and paste it over here. Okay. Oh, and I'll go ahead and comment out this part over here for you to use over here. Okay, and so now let's go ahead and make it and use what you have over here to turn it into a password that will have at least one capital letter and at least one number. Okay, make sense to everybody? So let's go ahead and share the code. Danielle, that is correct. You could do that. You can be a bit more advanced with what you decide to replace. So while you're all working on that, let me go ahead and just simply pull that up over here in idle. So let's go ahead and say word is equal to apple. Okay, so let's go ahead and say if we decided to do word.replace, and so we've got old and new, returns a copy of with all occurrences of the substring replaced by the new. So what we're going to do is we are going to go ahead and let's say if we wanted to replace the P's with more L's, right? So I'll go ahead and execute that. And it does exactly what we see. But if you decide to be a bit more, it's not just single letters. You can do something, a bit more advanced. You could do something like, let's see. Well, I could replace all instances of apple with a banana. So I can go, oh yeah. If you're trying to run, are you trying to run, Steven, are you trying to run this?
No, I keep hitting it by accident. I keep going down to load all of them and it just keeps.
It will freeze it for a minute because it's doing a lot of computation. So don't, I guess. Sorry. That will, okay. So we can also replace apple. We can do word.replace. We can do, if we see PPLE, we can replace that banana and it becomes a banana.
Also, Mr. Rawson, I have a question. I was looking for the records earlier. Where do I find them?
The recordings are found, the recordings?
Yes.
Home. So first page you're going to come to? Right here in the middle.
Oh, I see. I kept going to Zoom. Okay. I see.
Yep. No worries. You're not the only one. I've gotten actually multiple emails about that today.
Thank you.
Okay. So. And the reason you won't find them on Zoom is because I don't store them on Zoom. I store them on, I record on my computer. All right, so now knowing this, what we could do is that we can take our password, right? And we can do password dot replace. Why are you dancing around? Okay. Password dot replace. Let's replace all O's. Let's just focus on replacing the vowels. Plus replace O's with zeros. And that will be, and we need to update what the password is as a result. So replace all the A's with 4s, all the E's with 3, and actually that should cover it. And so, and then password is equal to password dot capitalize. Then let's print it out again and see what we get. Save and run. And there, we've got something there. The only place this could fail, though, if it starts with an A or an E or an O, right? So, which is okay. Oh, see there. I don't have a, we don't have a 0. I mean, I prefer to record on my computer locally just because that gives me, if I need to edit something for some reason, say somebody decides to Zoom bomb a lecture or something, I can edit it on my computer afterwards. Okay, so, all right. So now let's go and take a look at this last exercise or last 20 minutes of class. I really like this one because this is kind of the opposite. Here we were trying to create a password that was nice and easy to make, especially up here, make a nice password that's easy to remember, but hard for a computer to crack. Let's go ahead and take a look at this password, by the way, and do our math. Okay. So there's only 26 different kind of characters, but there's a lot more of them. I can find out how long a string is, by the way, by pasting it into the length, is by calling the length function. There's 31 characters. We had 62 to the 8th earlier, but now we have 26 to the 31st power, 31 characters. That number is a lot bigger. How much bigger is it? If I were to divide these two numbers, this number would still be bigger than that. So the quotient would still be bigger than this number, I believe. It is orders of magnitude. If I had a million computers working on it, with each computer, we're doing a million operations a second, 60 seconds in a minute. Sorry, 60 seconds in a minute, 60 hours a day. Sorry, 60 seconds a minute, 60 minutes an hour, 24 hours a day, 365 days in a year, 100 years in a century, and 1,000 years in a millennium. Still would take 2 millennium to wait, no. Wouldn't take 2 millennium. Sorry. It would take 2 times 10 to the 21st millennium. To crack this password, if I had 1 million computers doing 1 million operations a second to crack it. Or something like that. Anyway, yes, this will freeze your page if you run this. Careful, because what we've got over here is that this sets a limit for 60 seconds. What we've got over here is something called my password. And this is introducing stuff, as it points out, that it's got stuff that we haven't covered yet, like a while loop, which is, and this Boolean statement starts out by saying done is equal to false while not done. So long as this evaluates the true, is it done? Well, not done. What's the opposite of not done? Oh, sorry. So, well, not, sorry, no, bad. What it does, it says, while not done. So done is false. The not makes that true. So this will keep going on. And so guessed password. If the guessed password is equal to my password, found it. So what we're saying here is that we've got a password over here and we're trying to randomly guess the password ABC. Does that make sense? We're trying to like simulate how long does it take for the computer to find it, to find this password. Okay, so we've got ABCD as our password. So let's go ahead and grab this useful fella over here. All the letters of the alphabet. Throw them over here. 4 I in range. What I'm going to do is that I'm going to basically say, hey, we've got our guest password over here. Guest password is equal to random.choice letters plus equals. And that's it, actually, I think. Found it after 0 tries? Oh, yes, yes. And then, so this is my, and then what I wanted is guess number. So let's go ahead, and I think it's more interesting to look at this completed code right over here. So found it after 101,973 tries. Okay, so what's going on here, right? Does everybody understand what the purpose of this loop is? First off.
It'll like randomly generate guessed passwords if you like code it correctly until it finds something that matches the password.
Yep. It is randomly guessing passwords until it finds it of length 4 until it finds ABCD. It has a time limit of 1 minute before it stops. Okay, so here what it says is, while we're not done, set the guest password equal to a blank, guest, and we're going to increment our guest number, which starts out at 0. 0. So we start, so basically every time we go through this outer loop, this while not done, we add 1 to the guest number. And what we do over here is what we've been doing earlier. We just randomly select a letter from choice and add it to the guest password. Thomas, the answer is no, and I will show you why in a minute. If guest password is equal to my password, in other words, if basically I found the password, it will tell me how many guesses it took, and then say set done is true, which will kill the loop. So because done, while not done would be false. So, and so this can take a while, right? That was 2.1 million tries. 2.1 million tries to find that password. Enough. Oh, and here I found it in about 500,000 tries. So randomly guessing passwords like that isn't necessarily the smart way to do it, but I mean, it works. Okay, so now, yeah. And I was kind of showing this part earlier. What happens if you change the parameters? The person who wrote this says his MacBook Pro averages around 16,000 guesses a second. But our thing that uses 1 million guesses a second. If we had 1 million computers working in parallel, making 1 million guesses a second, we're looking not at just millennia, but like 2 times 10 to the 24th power. It takes basically forever to crack. Okay, now Thomas asked from another programming language question, which is, can plus equals 1 be written like plus plus in JavaScript, right? For those of you, to remind you, x is equal to 7, x plus equals 1. All that does is increment it by 1. Now, Thomas wants to know, does this work? And you'll see that this gives you invalid syntax in Python. And there's a very, very, very relevant reason for this, and it all goes back to readability. But you're like, but that's pretty easy. Plus plus means 1 more than. Well, what's often forgotten about, and let's see, do I have JShell? Yes, I do. Settings. All right. Do I have a font size here? Okay. It may be hard to see this part then, so give me a second to boot up the older terminal. Nope. CMD. Command prompt. Here we go. Yes, that's smaller, but I can change that. I know how to change that very quickly to be something much easier to see. So JShell. So this is Java working in a REPL just like Python does. So yeah, I will share the challenge code, but this is important for people coming from other languages. So right, we set x is equal to 8. Sorry, int x is equal to 8 in Java. You gotta tell it what type it is. Okay. And you can totally do x plus equals 1. The same syntax works, right? So everybody see that? Y is equal to 10. Sorry, int y is equal to 10. Sorry, Java. So we've got ourselves an x and a y. Okay. So x plus plus is equal to, would basically say, hey, make that equal to 10. Okay. Now here's the question though, or here's the rub. There's also a plus plus x, which looks like it does the same thing because that just incremented it by 1. But that is not the case. It is not the case at all. Let's go ahead and set x is equal to 5. Let's go ahead and say x is equal to 4 and y is equal to 4. Okay, because, and here's the thing, you can do these operations in the middle of an operation. So I could totally say 1 plus y plus plus. Okay, so that means take 1. Now, what's the difference between plus plus y and y plus plus? Well, the plus plus means do the increment before you execute everything else. So that means that this 4 would become 5, which means that this answer would be 6. On the other hand, if I were to do y plus plus, this means that we would do the incrementing after. So it'd be 1 plus 4, which would make it 5, and then y would get incremented to 5 as well. So it became really confusing when you got stuff like this, which was x plus 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 y, which we can just shorten to this. Kind of. Well, I guess we can't, but x plus 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 y plus plus. There we go. And that, or x, or God forbid, x plus 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 y, which we can't shorten to what I just had, although I thought we could for the sake of humor. But as you can see, that gets really confusing really fast. And the answer to that was apparently 11. So yeah, the Python said none of that noise. No, thank you. Do not want. No bueno. So it said, so it limited, so it removed that from the language. It does not understand that in the language. Share code. Okay, so now let's take a look at this. We've got, so somebody said, why is it always giving you 0? Because you got to increment the guess number. Again, this is this was listed as challenge because it involves while loop and for loops and if statements. But the idea here was just trying to demonstrate that basically it's not hard to guess a short random password. But once we get a longer and longer and longer password, it becomes much quicker. If we were to make this a much, A, B, C, D, E, and change this to 5, it actually takes 26 times longer. Why 26? Because we have all the combinations we had to go to before, plus all those combinations had have another letter after them, which could be one of 26 different things. So that's why we have 26 times more. It takes 26 times longer. Each letter adds 26. Multiplies the number of possible combinations by 26. That's why longer passwords are better than more complicated ones, because longer, while it does take a bit longer to type, it's actually easier to type if they're all lowercase. All right. Any questions on this one? I know it may have gone over your, over the heads of some people, or it may have just been like overwhelming. That's okay. Please let me know in the response. Okay. Whether you were in your comfort zone, your learning zone, or the panic zone, as they call it. And if you were in the twilight zone, don't want any of that. Don't let me know. Okay. I've seen that TV show. It seems too weird for me. Okay. Now, on Thursday, and I did see the request for demos. I will take demos after this. Tonight on Discord, by the way, or I'll be streaming on Twitch and be doing and probably doing a bit of music composing on Twitch, most likely. Some VR plus some music composing. But on Thursday under assignments. So again, I'm sorry that these links aren't working down here. I didn't realize that because I never click on them. And so I'll try to get that fixed. But if you go over here to modules, you'll see over here, the assignment will have on this. Yes, lab 4 is due before lab 5. We will do lab 5, most of lab 5 in class on not this upcoming Thursday, but the Thursday next week. Thursday is going to be basically review and Q&A of using loops and functions, because functions are really important. They're really powerful and they make your code a lot easier and a lot cleaner, and they're really awesome. The only thing about the for loops now that is being reworked is how many points it's worth. And then I'm working on the quiz, which you shouldn't challenge before your lab. Okay, so I should hopefully have the quiz up tonight or tomorrow. Okay, stop share and stop recording.